Welcome back to Industrial Problem Solving. My name is Dave Roysum. In this module, we continue the discussion of well-known as well as lesser-known formal methods of problem solving. Please also stay tuned for the next couple of modules where we will add faster and sometimes better methods that I call the street smart methods. In the last module, we discussed science and statistics. In this module, we introduce formal methods that you've probably heard about if not also used, such as 5S and 6 Sigma. We also cover a few other methods that are maybe not as well known, but still quite useful in certain applications. These are the Fishbone Diagram, the Duncker Diagram, and Kepner-Tregoe. Amongst these many toolboxes, you will find many useful individual tools. Again, the intent is not to teach the method. This would take 15 weeks of classes instead of 15 minutes. The intent is to list places where each method might work well, and then places where the method might not work so well. The challenge is not so much to know a particular method. You merely need to go to school or read, and then practice some more. The challenge is to know which toolbox and which tool in that toolbox is the best for the problem you are currently working on. This is very difficult to codify or teach. All I can say is that experience helps by developing an intuition about what tool might fit best. Again, laziness is vital. While there may be 2 or 3 or more methods that might work, the one that is fastest for you will be the best of all. My favorite of all formal programs is 5S. To say that I adore it would not be nearly expressive enough. It is often the best place to start. If you want a mnemonic, think 5 always comes before 6. Yes, you might be able to figure out a problem with other methods, but if the plant has a culture of messiness, the fix may not be long-lived. To say that 5S is common sense, a mother's common sense, is true, but it does not do it justice. Common sense is not all that common. Also, there is much fine detail in the application. Let me close with one final thought about an overriding industrial engineering principle. That is, it is far better to not make a mess in the first place than it is to allow disorder and then put a system in place to order it. That is the essence of 5S. No discussion of problem-solving methods would be complete that did not at least mention the most well-known of all. What began 3 decades ago as a statistically driven method of identifying and then reducing manufacturing variabilities grew and grew and grew and grew. It has now borrowed or stolen many tools from many other toolboxes. That is perhaps its greatest advantage, because it is now the largest toolbox. That is also its greatest disadvantage, in that it has sucked all the oxygen out of the problem-solving room. Other methods, perhaps even those more suited, will not be heard, much less considered. Other thoughts are not permitted. Let me give you just one example that I've spoken on in many variations and in many venues. That is, the economic number of defects is not 0 or 6 sigma low. Same is true of customer complaints. 0 is seldom best. Same is true of waste. The optimum amount of waste is when the cost rate of waste recovered equals the rate of cost increase to reduce that weight. Yet, 0 defects and 6 sigma puts in place a less waste is better ideology instead of a more profit is better economic objective. Whether you have seen my discussions on this subject or agree with them, I think we can all agree that in a 6 sigma environment, most problems will look like a 6 sigma candidate. This is a variation of the if you have a hammer, everything looks like a nail. The Fishbone Diagram divides a task down into discrete major components and then subdivides those major components into as many possible options. While it can be used for certain problems, mainly optimizing workflows or invention, it is not so applicable for many of the problems we work on. Still, the wider the set of tools you have, the greater the range of the problems you can work on effectively. The Duncker diagram is a similar idea to the Fishbone diagram. However, it has one new idea that I absolutely adore. That is, to plan for failure with near equal attention as the plan for success. This is built in at the top level for good reason, because failure is common. While much can be said of burning the bridges, so incentivizing the workforce, you may find you need those bridges if things don't go as planned, as they often don't. So here's an example I made up for quitting smoking, a subject that I have personal experience and expertise. Note how the Duncker insists that we also plan on failure. This is particularly useful for the smoking example because it takes, on the average, 5 very serious efforts before a smoker succeeds in quitting. In the meantime, even though they have failed this time, they should not give up. In the meantime, as Duncker teaches, they should redouble their effort for a healthy lifestyle in other ways, such as exercising and eating right. Kepner-Tregoe is probably second only to Six Sigma with respect to industrial penetration. In some industries, such as paper, it may be number 1. You can go to school on it. In fact, I did. And you can get certified in the program or hire those who have been certified as adjudicators. Kepner-Tregoe, or KT for short, is very much a recipe-based approach that leaves little room for improvisation. It starts by listing knowns by answering the who, what, when, where, and why type questions. The method is almost always done as a group exercise, which has its own pluses and minuses. Once data is gathered, you continue to make a working theory that best satisfied the data just discussed, and then on to option brainstorming, and then finally to decision making. I have very mixed feelings about this program, which I've been a participant on many occasions. It is a bit of science by consensus, and thus slows the process when science or experience does have something to say, particularly only if a couple people possess that particular science. Most times, it utterly failed for a variety of reasons. It is not reasonable to expect that if it takes one person 30 days to figure something out, than putting 30 people in a room can get it done in one day. Contrary to what is often taught, the optimum size of the core group of problem solvers is 2 or 3. However, I once saw KT succeed brilliantly on a very complicated machine design issue that plagued one plant, but not its sister plants that had different designs. No one knew why. 30 people from a variety of disciplines, from operators to VPs to outsiders, were managed by a KT expert. We were given 3 days to figure out the problem, and a very expensive machine was made available to us to try anything the group suggested. Thank you so very much for joining me in this continuation to the problem-solving process. In the next clip, we will begin a much more detailed discussion of my favorite section of this course. That is, the street smart methods that I most often use. Stay tuned.